for the lecture on isomers. Isomers are classified into two types. They are structural isomers and stereoisomers. Stereoisomers are further classified into two types. They are configurational and conformational isomers. This lecture focuses on the nomenclature of configurational isomers. The configuration isomers are further classified as diastereomers and enantiomers. So, the stereoisomers, there are two types. One is conformational isomers. Conformational isomers are nothing but they are the stereoisomers which are differ in rotation around the single bond. For example, if we take ethylene molecule, there are two carbon atom. In each carbon, there are three hydrogen atom. In this isomers, the hydrogen atom in carbon are eclipsed with each other. They are present in same side. This isomer of ethylene is known as syn isomer or eclipsed isomer. When we rotate the carbon-carbon bond for 180 degree without breaking of the bond, here we are rotating the carbon-carbon bond for 180 degree. Now the two hydrogen atom present in each carbon become anti to each other. This conformation is known as anti-conformation of ethylene or staggered conformation. So that by rotating the carbon-carbon sigma bond, we get two isomers in ethylene. One is eclipsed, another one is staggered. Syn and anti-conformation. These isomers are known as conformational isomers. Another type of stereoisomer is configurational isomers. This isomerism arises only around the restricted bond. The configurational isomers can be interconverted by breaking the bond. For example, if we take carbon-carbon double bond, in that the pi bond is formed by side wave overlapping of the p orbital, so that this carbon-carbon bond cannot be freely rotated. This is the restricted bond. Around this restricted bond, if the two similar groups are present in opposite side, that means those isomers are known as trans isomers. Suppose around the restricted bond, two substituent, same substituent present in same side means those isomers are known as cis isomers. In some cases, the substituent on the carbon atom which are involved in the restricted bond are not same. They are differ from each other. In that case, we cannot use simply cis and trans configuration. Instead of that, we have to use Z and E configuration. For example, if you take this carbon-carbon restricted bond, around this bond, the high molecular weight substituent are present in the same side about the restricted bond, and low molecular weight substituent present in another side. That is, around the restricted bond, the high molecular weight substituent of each carbon atom present above the restricted bond, and a low molecular weight substituent present below the restricted bond. That means these isomers are known as Z isomers. Suppose the high molecular weight substituent in each carbon atoms are present in opposite side, and a low molecular weight substituent they are present in opposite side means those isomers are known as E isomers. Example, if you take this molecule, in that one of the carbon contain methyl and hydrogen as a substituent. Here the molecular weight of the methyl is higher compared to hydrogen. So this is high, this is low. Here in this carbon, one side ethyl is present, the other side methyl substituent is present. We know that ethyl is high molecular weight and methyl is low molecular weight. High molecular weight substituents are present on the same side and low molecular weight substituents are present in same side. So, this isomer is Z isomers. Take another example. Here, this carbon contain bromine and chlorine as a substituent. We know that atomic weight of bromine is 54 and chlorine is 35. So, that this is high molecular weight substituent, this is low substituent. In another carbon, one side ammonia is present, other side hydroxy group is present. This ammonia group, the molecular weight is 17, the hydroxy group also 17. Both are same molecular weight, but here in this side, the nitrogen is directly attached to the carbon. This side, oxygen is directly attached to the carbon. We know that atomic weight of oxygen is high compared to nitrogen. So that in this molecule, the high substituents are present in opposite side. Low molecular weight substituents are present in opposite side. So this isomer is E isomer. Like that, we can assign the configuration for E and Z configuration for the isomers. In the next video, we can see how to assign R and S configuration. Thank you.